Hi there, Banggood liked my previous review of the ST1472 radio so much that they sent me another, this time the Reteckess V115. I do not get paid for the video, but I do keep the radio, so I mark it as a promotion, but as you know, that doesn't stop me from giving you an unbiased review. In the box is a USB-C charging cable, an instruction booklet in 7 languages, and the radio itself. Where the previous one was in a 3D printed case and had just one rotary encoder to operate it, this one is quite a bit larger in a nice professional enclosure and has lots of buttons. Interestingly, the battery has been wrapped in plastic. Before use you have to unwrap. 1000 milliamp capacity apparently, BL5C, turns out to be a widely used common battery which was originally for Nokia phones but is now used in a lot of other devices. I'll have a more detailed look later. On the right side are all the connectors of this radio. In the middle is the SD card slot, which you need to populate with your own card to play MP3s or do recordings. On the top is the headphone output and a line input socket for recording from external sources. At the bottom is a USB charging port. With the radio off and a USB port plugged into a charger, you are treated to this display, possibly for several hours, since charging is not very fast. When full, the display changes to this instead. There is a vent at the rear marked optimistically with Megabus. I think the idea is to take that squarish piece of plastic that's attached to the lanyard and insert it into a slot at the back. That pops up the radio when lying on the table and boosts the sound. I have to admit, this works surprisingly well. This tune from the YouTube audio library is maybe not the best showcase, but volume and sound coming from this small radio is quite impressive. A quick look at the specs, copied from the Banggood website. The radio supports FM, AM and shortwave bands. You can select the FM band to start at 64 MHz instead of the default 87 MHz. The tuning on the AM is either using 9 kHz steps or 10 kHz. The audio format for the SD card is MP3 or WMA. Regardless of the band, there are only 2 ways of tuning. One way is to use long presses on the skip forward or back buttons, which causes the radio to start incrementing or decrementing the frequency in fixed steps and stop and unmute when it thinks it found a station. Since the search is muted, you would never know if it skipped a weak station, so they make the search stop at even the smallest signal, which is mostly just static. The only other way of tuning is to type the frequency in directly, which works in AM, shortwave and FM bands. I live in an area bad for radio reception, but by connecting a long wire extension to the telescopic antenna, I did manage to pick up a shortwave station. Say you were a spy and this was an important message for you, there is no need to sit with pen and paper. Provided there's an SD card loaded, you can just push rec and now the radio is recording the audio on the SD card. The display shows the length of the recording. When you press rec again to end the recording, the radio immediately switches to playback the recording you just made on auto repeat. You may wish to simply continue listening to the live broadcast, but sadly that behavior can't be changed. If you don't want the recording anymore, you can delete it and then the MP3 player will simply pick something to play back next. To test frequency accuracy of the radio, I set my signal generator to 15 MHz with 1 kHz AM modulation at 80%. It picks it up, but not that clear. I changed the modulation tone just to make sure it was my signal that I was listening to. The radio may be off by a few kilohertz, but since you can't manually tune the radio, it's very troublesome to check. Anyway, it's probably good enough for general use. You may have wondered what these channel numbers are, like 06. These are presets of which the radio has a lot. 80 for FM, 60 for AM and 300 for shortwave. The way to set them is to use the play button, which initiates another autoscan tuning, but this time the radio stores the frequencies where it thinks it found something in the next channel number and proceeds all the way through the band. I show this sped up. Sadly, it's not possible to assign a channel manually, for example, to a directly entered frequency value. As I mentioned before, during scans the radio picks up a lot of static, even on FM, so after the scan the manual recommends to go over the assigned channels and delete the ones that are bad. This requires a lot of muscle memory because many buttons have at least two functions, selected by long or short presses. To advance to the next preset is a short press on the search right button. A long one would start a new scan. To delete a channel is a long press on del, but to confirm it's a short press on the play button. While I'm doing this tedious cleanup, let me tell you that when listening using headphones I had the distinct impression that all FM radio was mono only, while pre-recorded MP3s were playing in stereo. To find out, I connected the radio via USB. The SD card shows up as a normal USB media. Upon the first recording, the radio creates a folder Record with 3 subfolders: AUX, Mix and Radio. Inside, it numbers the recordings, for example AUX 001, AUX 002 and so on. Anyway, if I open the radio recording, RAD 001 in Audacity, it's clear that both channels are identical. Later I inverted one channel and added it to the other channel and the result was a flat line, but I somehow lost the video for that. The recording itself is clearly meant for good quality stereo MP3 with 320 kilobits per second at 44.1 kHz. When I compare this with an AUX recording done via the line-in connection, it is clear that this is a stereo recording. The two channels are different. It becomes clearer when I zoom in a bit. The media info for the AUX recording is identical to the radio recording format. Good quality stereo MP3 with 320 kilobits per second and 44.1 kHz. For comparison, the built-in microphone records mono at 160 kilobits per second and 32 kHz. By the way, you can set the recording quality in 3 levels in the system setup menu, and I selected the best quality. And speaking of microphone recordings, you can leave a memo on this little radio. To open the radio, I decided to remove the battery first, another instance where the little plastic square on the lanyard comes in handy. There are 5 little self-tapping screws spread around the perimeter of the radio. I also removed the big screw holding the aerial, but this is actually not necessary. One has to be really careful when opening, as there are very fine wires to the AM ferrite antenna coil that can easily break. The microcontroller is marked TheHWcave14R5A. I was not able to find a datasheet for this one, but then I did not spend hours on the search either. The T25S80 is an 8 megabit serial flash memory chip. Obviously this is where, for example, the channel presets are stored. I did not find the KT093A, but I did find the KT09R, which is a fully integrated FM, AM and shortwave receiver chip. The R variant is definitely capable of stereo reception, but it's possible that the A variant in this radio is not. Lastly, the Mix 2018 is a 4.8 watt mono audio power amplifier for driving the speaker. It is intriguing that the PCB contains what looks like possibly a Bluetooth antenna, but the antenna tracks lead to an unpopulated area, so obviously nothing's happening here. Lastly, the mystery of shipping the radio with a wrapped phone battery. The battery is marked where the plus and minus connections are. Just for good measure I used the meter to confirm. No problem here. The question is, what's the third connection in the middle for? It may be a temperature sensor like an NTC or some form of a charge indicator. 67.5 kilo ohm between the middle pin and ground sounds a bit high for an NTC at room temperature. It might be a charge indicator, but let's leave it at that. More importantly is to measure the current drawn by the radio. For that I connected probes to the 2 outer terminals. The battery compartment helpfully has indicators where plus and minus should go. With the radio carefully balanced on its probes, I connected the multimeter in current mode between the radio and a bench power supply set to 4 volts. When I turn the bench power supply on, there's a brief rush of 13 milliamps even though the radio is off. And changing the range from milliamps to microamps reveals that this radio is drawing nearly 10 microamps when turned off. I don't think this current is the reason that the battery was ship wrapped, because it would take more than 11 years before that would drain a fully charged 1000 milliamp hour battery. More likely to avoid bumps and knocks during the shipping accidentally turning the radio on. Which brings us to what does it actually draw during operation. About 53 milliamps on MP3 with backlight. 85 milliamps or so on FM with backlight. Same on AM. About 64 milliamps on FM with no backlight and low volume. If we take 75 milliamps as an average for radio and 50 milliamps for MP3 playback, the battery should be good for 13 hours of radio and 20 hours for listening to MP3s. All in all, it's an inexpensive little device that has its uses, and on FM and MP3 playback offers great sound from its speaker. Keen shortwave listeners will love the direct frequency input, but not so much the lack of manual tuning or preset assignments. Other users may love the ability to record stereo MP3s from a line input signal. If you are interested in getting the Reteckess V115, I leave links in the description. If you like my videos, don't forget to subscribe if you have not already, and maybe consider becoming a Patreon. That would really help this channel. The link is in the description. As Patreon, you always get early access to videos, a blog and other exclusive content. Thanks for watching.